السلام عليكم. عاملين يا طلاب؟ إيه اخباركم؟ احنا بنتكلم مع طلبة سنة تانية شعبة اللغة كلية التجارة جامعة أسيوط. We have started um, speak about some measure of central tendency, and we say in chapter 3 كنا اتناقشنا مع بعض في central tendency الموجودين في chapter 3 أو الأفريج بصفة عامة. This average includes mean, median, mode. The mean is the best of them. المين هو الأفضل if it has no outliers or no open-ended distribution. لو كان عندك outliers أو open-ended فالمين في الحالة دي مش تقدر تقول إن هو الأفضل. Why the mean is the best? The mean is the best because we use all the values to calculate the mean. بناخد كل ال values عشان نحسب المين، فعشان كده بنقول إن هو الأفضل. طيب the median is looked as the middle term of ranked data. بنقول ان هو القيمة اللي في النص لما ترتب البيانات، وبنقول ان الميديان is better than the mean in two cases. في حالتين الميديان يكون افضل من المين. لو انا عندي if we have open-ended distribution or if we have outliers. واتكلمنا بعد كده عن المود. we have spoke about the mode and it is the most highest value we have, and we have this important relation between the mean, median, mode. It is mode equals 3 median minus 2 mean. Okay, when the geometric mean we use it for some special cases, and we have seen which one is better. Now if we have the following values 50 100 150، لو عندنا 3 قيم 50 و100 و150. if we want to compute the mean for this value, the mean will be 50 plus 100 plus 150 over 3. It is 100. Okay, if we have the following value 99 100 101, the mean for these values is 100 also. يبقى المين في الحالة الأولانية كان 100 والتانية كان 100. But it is better to describe which cases, to determine which cases is better described with the mean. Yes, it is a second case, of course. In this case we say that the mean is better for the second case than the mean for the first case. ليه؟ لأن هو بيوصف البيانات أكتر because it describes more data or most accurate for all the data here. Okay, we want a measure to describe if the central tendency we are going to use is good or not so good. This measure we call it measure of dispersion. As the data has a lot of dispersion, the central tendency is not going to work well. لو كان عندك الداتا بتاعتك فيها اختلافات كتير dispersion عالي، ففي الحالة دي بنقول عليها ان احنا مش هنقدر نشتغل عليها باستخدام central tendency. So we say that the measure of central tendency don't indicate the extent of dispersion or validity in a distribution. A high degree of uniformity, this means low degree of dispersion, is desirable quality. طبعا كل ما بنحاول ان احنا البيانات بتاعتك تكون فيها uniformity يعني انتظام نوعا ما، فبنقول البيانات في الحالة دي ممكن تتوصف بالcentral tendency better. Dispersion or spread is the degree of the scatter of variation of the variable about the central value. Okay, for example, if we have three different series. عندنا 3 series مختلفين: series A, series B, series C. series A all 100, B 100, 105 and so on. series C is 100, 489 and so on. The mean of these three sets are 100, but the mean describes the first data's best. It describes the second data be good, but it is not so good for the third case. We say that the dispersion here play a lot of well. This means if we have three different cases, for example A, B, C, A, B, C, here we have the same mean of the data, but do you think it has the same figure or not؟ لو بصيت على الشكل تلاقي الشكل مختلف، صح ولا لا؟ the figure is not the same. In the first case, this means that all the data are close to our mean, but the second one, the data doesn't have the same mean, the same dispersion. It has more dispersion, so we cannot say that it has the same dispersion. So the mean for the first case, it will be better than the second case. In the second, we have the mean is not the same for both data, but it looks like the data have the same shape. البيانات ليها نفس الشكل لو بصيت عليه، بس مع اختلاف ايه؟ السنتر بتاعها فين. السنتر التندنسي بتاعها اللي هو المين ممكن يبقى هنا وممكن يبقى هنا وهكذا. طيب here we have two different figure، عندنا شكلين مختلفين نهائيا لو بصيت عليهم ده وده، with different means، الشكلين برضو مختلفين. اوكي. Measure of variation point out as to how far an average is representative of the mass. To determine nature and cause of variation in order to control the variation itself, comparison to be made of two or more series with regard to their variability, many powerful analytic tool in statistical based on measures of variation. This is why we use we significant look for variation. For example, the second cause, to determine nature and cause of variation in order to control the variation itself. لو احنا بنتكلم على blood pressure for sample or people, and we have a variation in some people, we are looking for how to solve this problem to come as close as to the mean. So this variation needs to be controlled. And moreover, if we are going to compare two different set of data and we want، لو احنا عاوزين نعمل مقارنة بين two sets or more, we want to see if they have the more the variability a lot more the variability in each set. And last, we have many powerful analytical tool in statistics based on measures of variation. احنا عندنا في الاحصاء بنلاقي في حاجات معينة كده في تحليلات او في اختبارات بنبنيها على الفاريشن ده. How we can say this is a good measure of dispersion? To say this is a good measure of dispersion, it should be simple to understand. Of course, any statistical measure should be simple to understand, so the same for the dispersion. It should be easy to compute to understand, of course. It should be rightly defined. It should be based on each and every item of the distribution. طبعا كل ما بتزود البيانات اللي بتعتمد عليها كل ما بنقول measure ده أفضل بصفة عامة في ال statistics. It should be amenable to further algebraic treatment. ممكن انك تعمل معاه بالجبر تحليلات بعد كده لو انت محتاجها. It should have sampling stability. Extreme item should not be influence it. Okay. We have different measures of dispersion: range, interquartile range or quartile division, mean division, standard deviation, and Lorenz curve. احنا عندنا في مقاييس مختلفة للدispersion، في منها او اهمها اللي هي الرينج اللي احنا بنسميه بالعربي المدى، interquartile range او اللي هما بيسموه نصف المدى الربيعي، quartile division او الاختلاف الربيعي، mean division و standard devision. standard devision اللي هو بيترجموه الانحراف المعياري، و Lorenz curve. First we will start with range. The definition of the range: it is the largest value minus smallest value, the difference between the smallest and largest value. الفرق ما بين largest وال smallest اللي احنا بنسميه range. For example, if you have this set, for the first set the range is the difference between highest and smallest. The second set is the difference between highest and smallest. و third برضه نفس الكلام. هل دي فيها مشكلة؟ I don't think there would be a problem to find the range for these three different sets. Okay, if we have a frequency distribution and we want to find the range for it, what are the values? خلي بالك في فرق ما بين الكلاسز اللي بتعبر عن الفاليوز وما بين الفريكونسي. The range is for the values not for the frequency. الرينج للفاليوز مش للفريكونسي. تمام بهوت؟ طيب for this data the highest value, which value will be the highest? It is 120. Yes. The smallest value, it is 20. So the range in this case equal 120 minus 20, it is 100. Okay, what is the limitation of the range? The first limit, we have it based only on 2 items and doesn't cover all the items in the distribution. طبعا هو بيعتمد على قيمتين بس، ما يعتمدش على اي حاجة تانية في الديستريبيوشن بتاعنا، فده عامل لنا مشكلة. It is subject to wide fluctuation from sample to sample based on the same population. ممكن انا بختار سامبل معينة واختار سامبل تانية من نفس البوبوليشن، بس نتيجة ان القيم اللي موجودة موصلتش لحد معين او اقل قيمة مكانتش وصلت لحد معين، الديفرنس هيختلف من السامبل التانية بسهولة. It fails to give any idea about the pattern of the distribution. الديستريبيوشن مش تقدر تحدد ايه شكله ولا ايه اتجاهه لانك اعتمدت على قيمتين بس. Finally, in the case of open-ended distribution, it is not possible to compute the range. طبعا لو عندنا open-ended distribution مش هنقدر نحسب الرينج في الحالة دي. What is the advantage? It is widely used in quality control. الquality control بيعتمدوا عليه كتير جدا. ليه؟ لأن هو مجرد حسبة سريعة بيقدر يحسبها ويقدر يكمل الشغل بتاعه. Where a continuous check on the variability of raw materials or finished products is needed. The range is also a suitable measure in weather forecast. بنشتغل بيه في قياس الوزر او الطقس بتاعنا. ليه؟ لان انت عاوز difference in degrees. For example, it is going to increase by 3 degree, going to increase by 10 degrees, so on. You are going to focus on the range only. Of course, we are going to use something different now. We are going to use something called interquartile range. Interquartile range, it is quartile, third quartile minus the first quartiles. It's the difference between the first and third quartiles. We use IQR for this interquartile range. If we divide this difference of quartiles over 2, we say it is semi-interquartile range. Some say it is quartile division. Be careful if we have a symmetric distribution. If you have a symmetric distribution, so the value which is smallest than the median is the same as the highest than the median as definition. Yes, لو انا عندي symmetric distribution والتعريف بتاع الميديان بتاعي بقول الفاليوز اللي اقل منه اكتر من الفاليو قد الفاليوز اللي هي اعلى منه. This means that in this case also the first quartile اقل منه الربع واللي بعد منه 3/4. So in this case you will find for the symmetric distribution median, the difference between the median and the first quartile is the same as the difference between the third quartile and the median for the symmetric distribution only. في حالة السيمتريك عشان متلخبطش ماشيين مركزين بهوت، معلش انا عارف انكم مش متعودين على الكلام ده. اوكي، merits of interquartile range. As compared to range, it is considered a superior measure of dispersion. طبعا لما بنيجي نقارنه بالرينج، الرينج كان عبارة عن فرق ما بين two values، فبنعتبره ان ده افضل منه بكتير superior. In case of open-ended distribution, it is quite suitable. طبعا احنا شفنا ازاي بنحسب الكوارتايلز قبل كده وكنا ناقشنا الكلام ده. Since it is not influenced by the extreme values in a distribution, it is particularly suitable in highly skewed or erratic distribution. Of course, one of the most advantage of the median and the quartiles that if you have some extreme values you can use it and it is going to leave the influence of the extreme values. طبعا مش هتتأثر بالاكستريم values لو انت عندك extreme values، فبالشكل ده ممكن تشتغل على الكوارتايلز والميديان بسهولة. Limitation about the interquartile range. It fails to cover all the items in the distribution. It is not amenable to mathematical manipulation. It varies widely from sample to sample. Since it is positional average, it is not considered as measure of dispersion. For example, in the table we have studied before, this one, we want to find the value of the three quartiles and find the interquartile range. Of course, how to find the quartiles, and it is the same way as the median. Do you remember how we calculate the median? فاكرين يا بهوات كنا بنحسب الميديان ازاي وبنحسب الكوارتايلز ازاي؟ ايوه تمام. First we start with ordering the data ascending. We need here to be sure that the data will be ordered in ascending way. This is the data. We specify the position of the median. Position of the median equal n plus 1 over 2. It is 6.5. Then the median is between the 6th and 7th value here. So we say that the median equal the mean of these two values, summation over 2, it is 84.4 45. Okay, where is the first quartile? The first quartile is the midpoint of the data less than the median. So we have 6 values less than the median. So the midpoint of it is between 3.5, between third and fourth value. We have the summation over 2, it is the first quartile. The same way we will find the third quartile. Of course, then we say that where does the revenue of 103.5 million fall in the relation of these 3 quartiles? 103, it is the highest value of the third quartile. So we say that it is one of the top 25% of the revenue in this case. To find the interquartile range, it is the difference between the third quartile and the first quartile, so it is substitution only. For the following example, the following are the ages of 9 employees of an insurance company. Find the value of 3 quartiles, find the interquartile range. It is an easy, so arrange it in ascending. You will find the median to be the we have here 9 values, so 9 plus 1 over 2, it is the fifth value, it is the median. The first quartile is the midpoint of the value, which is this the median. We have 4, we take median in between the second and third value, it will be 30.5 and so on. He asks you where is the age of 28. The age of 28 is in the lowest 25%, so in this case it is in the lowest, and we can find easily the interquartile range with substitution with the first and third quartiles. We have something called box and whisker plot. Box and whisker plot is the application for the quartiles and the median. As a definition for it, طبعا box whisker plot احنا بنشتغل بيه كتطبيق على الميديان والكوارتايلز الموجودين عندها. Definition: a plot that shows the center, spread, and squeeze of a data set. It is constructed by drawing a box and 2 whiskers that use median, the first quartiles, the third quartiles, and the smallest and the largest value in the data set between the lower and the upper inner fence. Okay, I know you are not going to understand the definition easy without an example, so we will have an example. The following data are the incomes in thousand for a sample of 12 households: 35, 29, 44, and so on. Construct box whisker plot for these data. Of course, the first we will use we need to calculate the median, the first quartile, third quartiles. So we will arrange the data in ascending order. We have 2, 4, 6, 8, 10, 12. We have 12 values. So the median is between the 6th and 7th value. It is 44 plus 50 over 2, so this is the median. The first quartile can easily found to be 37, third quartile is 61. We can compute the interquartile range as the difference between the quartiles first and third one. Okay, step 2. We take 1.5 constant. عندنا هناخد 1.5 دي constant ثابت ملناش دعوة ما بيتغيرش times interquartile range. Then 1.5 interquartile range we have computed here, it is 24, it is 36. We define lower inner fence as lower inner fence عبارة عن الكوارتايل الأولاني هنطرح منه الفاليو اللي انت جبتها فوق دي. lower inference equal first quartile minus 36, so it is 1. upper inference, it is the third quartile plus the 36 you have computed earlier. So we have here lower and lowest inference. So we have the median, we have first quartile, we have third quartile. So if you have the line number خط العدد اهو، وده الميديان وده الفيرست كوارتايل، ده الثيرد كوارتايل. Okay, we have lower inner fence and upper inner fence. Lower inner fence is 1, so the lowest value here is not 1, it is 29. So the smallest value in inner fence we have is 29. The highest value here 104, so we can say that the upper inner fence will be the same. So the smallest value within the two inner fence is 29, the largest value within two inner fences 72. So this is the smallest value we have, and largest value within the two inner fence which we have, which was 72 here. Okay, yes, we have a point here which is 104. This value is out the range at all, so this is called box whisker plot. So the box whisker plot, we have the median, we can find the median here, it is the corresponding value, the first quartile and the third quartile, and lower smallest value within the two inner fence and largest value within the two inner fence, and this is an outlier. Okay, what says about our distribution? First of all, it says that we have an outlier. It is close. It is easy to see that we have outlier. Yes or no? Yes. The outlier point should be put inside a circle if we have 2 or 3 points outside, so we have different points here. Okay, this is the first case. Second case, we can say that the difference between these ones, the median and the third quartile, is greater than the difference between the median and the first quartile. So we say that it is right squeeze. So you can say how squeeze look like from this shape, and how if you have outliers or no. All of this you can found from the box whisker plot. Of course, it is something we are going to use it more and more. طبعا حضرتك احنا اتكلمنا النهاردة كحضراتكم we have talk about the dispersion, the definition, how we can find good measure of dispersion. اتكلمنا عن الرينج، اتكلمنا عن الكوارتايلز واشتغلنا بيهم. مش عاوز اطول عليكم عشان متزهقوش بسرعة، بس يا ريت حضراتكم تحاولوا تتابعوا المحاضرات وحاولوا تشتغلوا بايديكم الامثله الموجوده في الكتاب. يا ريت حضراتكم يعني تلتزموا بتعليمات الصحه. ربنا يحفظكم من كل سوء يا رب، ويحفظ عائلاتكم ويحفظ كل عزيز عندنا وعندكم، ويكشف البلاء الموجود في العالم دون، ونرجع نشوفكم بخير وسلام في الكلية. وحشتونا والكلية بنضلها من غيركم، بس ان شاء الله صحتكم اهم، وان شاء الله ترجعوا للكلية بصحة وسلام. هنقف النهاردة هنا هون، ونشوفكم في المحاضرة اللي جاية ان شاء الله. هنشوف اذا كانت هتبقى اونلاين ولا هتكون في الكلية. صحتكم اهم وربنا يحفظكم. شكرا ليكم. سلام.